Hi guys, so this is 11.4 series and their notation. So we're going to be talking about series. So series as opposed to sequences, right? Series are when you're adding them together. That's basically the difference between a sequence and a series. Series specifically is the sum of all of the terms, whereas a sequence is just, you just list out the terms with like a comma in between. Anyway, first thing I want to talk about is summation notation. So summation notation is this thing here with sigma, and it's used with sequences and series. It's also used with limits when you get to calculus. That's probably the place that you end up seeing it most if you go into higher math. Anyway, it's really useful because it's just a shorthand way of writing out a long sum like this. And you can have, 100 terms wrapped up in this one little expression. Because basically the first term number, you could say, goes here. This is called the lower limit of summation, but basically the first number you're going to plug in for k goes here, and then the last number goes here. So you can have any number of terms wrapped up in this where you're just plugging in, say, 1, and then the next term you plug in 2, and then 3, and then 4, and then 5, because that's the last term. That's the number here, then that's going to be the last term. So this particular series has 5 terms, but it could have as many as you want it to, which is what makes this this notation so useful, right? Is because we can put a lot of terms into a very compact notation. I don't have to write out 50 terms. I can just say, okay, this goes from 1 to 50, and then I'm done. Anybody can find my 50 terms without me having to write them all out. The index of summation just tells us what letter we are plugging the numbers into. So which variable I'm plugging the numbers into. And this is important because sometimes you might have a more complex situation where you have more than one variable in here. And I need to know which one I'm plugging the numbers into. So in this case, it says K. A lot of times we use N, or I is also really common. Not in this chapter, but in math in general. Having I as your index of summation is really common, which is not surprising because it's called an index, and so the first letter of index is I. So people like to use I. All right. And then this is the explicit formula of your sequence. So in the last couple sections, we've talked about the explicit formulas for arithmetic sequence and geometric sequence. So that would be what would go here, and that's the explicit formula, not the recursive formula. So that's what goes here. Anyway, and then, like I said, you would just plug in 1 through 5, and that would give you your terms, and then you could sum them up. Okay. So that is summation notation. And yes, so this one, I did want to talk about this. This one starts at 3. So we're used to it starting at 1. It doesn't have to start at 1. It could even start at 0. This one starts at 3. So instead of plugging in 1, 2, 3, 4, 5, 6, 7, you just plug in 3, 4, 5, 6, 7. So this is telling you where to start, right? It's telling you to start at 3. And then to figure out how many terms you have, you could do this and then count them. But if, say, this goes up to like 52, I don't want to maybe plug in and count them if all I need to do is know the number of terms. So to find the number of terms, we just subtract this number minus this number and then add 1. So 7 minus 3 is 4, plus 1 is 5. And the reason you have to add 1 is because when you subtract, right, you're getting rid of not just all of the numbers before 3, you're also getting rid of the 3 itself. And so you have to put that back on, so you add 1. So it's always this number minus this number plus 1. If this is 1, then the number of terms is just the number up here. Because anything minus 1 plus 1 is just whatever you started with, right? So if this is 1, then the number of terms is just this number. Otherwise, you use that formula I just talked about. All right, let's talk about arithmetic series specifically. So if I want to find the sum of an arithmetic series, I need a formula for that. And I mean, you could just plug them in and find them and add them up, but that would take a long time, especially the bigger the sequence is, right? The bigger the series is, the longer that would take. So I want something that makes it faster. So someone very smart realized we already knew this, right? That I can write out an arithmetic series like this. I'm just adding d each time. And then another way I can think about adding d each time is if I start with the last term, I could subtract d each time. Does that make sense? So going from the first term, I add d each time. Going from the last term, I could subtract d each time. Okay? I can rewrite this. I can rewrite it in the opposite direction, right? I can start with the last term and subtract d each time. And then when I'm getting towards the end, I would be adding d each time to the first term. So this is literally just writing this starting at the other end. That's all this is. Now we know we're allowed to add equations together. So I'm going to add these two equations that we just wrote up here. Just going to add them together. And I start noticing something. So here I get a1 plus an. Here I get a1 plus an plus d minus d. Well, plus d and minus d cancel out, so I just get a1 plus an again. Then here I get a1 plus an plus 2d minus 2d. Oh, those canceled too, so I get a1 plus an again. Here I get an plus a1 minus d plus d. D's cancel. Hopefully we're seeing the pattern here. I'm getting a1 plus an every time. So I just have a bunch of a1 plus an's. And how many of these do I have? Well, I have n of them because I had n terms in this equation and I had n terms in this equation. So I must have n of these. So I can just rewrite this side as n times a1 plus an. And on this side we have 2s n, right? Because I was adding these two together, so I have 2 of them. So I just need to divide both sides by 2, and this is my formula for the sum of n terms of an arithmetic series. So all I need to know to find the sum of an arithmetic series is how many terms I have, the first term, and the last term. That's all I need to know, and then I can find my sum. So let's do an example or a couple examples. So with this one, I'm given the whole series. So I can count the terms, and there are 10 of them. So I can count them. I see that there are 10 of them. I take the first term is 5, the last term is 32, and I just plug that in. So I have 10 terms. The first term is 5, the last term is 32. So I have 5 plus 32 times 10 divided by 2. I get that my sum is 185. And remember, this formula only works if the series is arithmetic. If it's not, then I can't use this formula. For B, I have my first term as 20. My last term is negative 50, but I don't know n. So I have to figure out how to find n in this situation, the number of terms. Well, I know the general form of the explicit formula for an arithmetic sequence, right? We talked about that a couple sections ago. So this is my formula that I know this has to follow because it's arithmetic. So I can just plug in the last term, plug in the first term, plug in D, my common difference, which I can just look at this and see, oh, I'm subtracting 5 each time. So I know that D is negative 5, so I plug in negative 50 as my last term, 20 is my first term, negative 5 is my common difference, and then I can just simplify that, or solve that, I should say. So subtract 20 from both sides, divide both sides by negative 5, add 1, and I get that n is 15. So I have my number. I already had my first and last term, so I can just plug those into my summation formula and get negative 225. For C, we have sigma notation. Oopsies. So again, the number of terms, if we start here with 1, the number of terms is just this number. So n is just 12 in this case. Or I could use my formula, 12 minus 1 plus 1 is still 12. I also need my first and last term. So my first term, I'm just going to plug in 1 here. So I get 3 minus 8 is negative 5. And then for my last term, I just plug in whatever number is here. So first term, I plug in this number. Last term, I plug in this number. So I'm just going to plug in 12 there. And I get 28. So first term, I get negative 5. Last term, I get 28. We were told we can use the notation to see that I have 12 terms. So I'm just going to plug that information into my formula, and I get a sum of 138. Okay. So the next thing, sorry, I just wanted to see if there was anything else I wanted to talk about with arithmetic series. There isn't. So in the next video, we're going to talk about geometric series. So let me know if you have any questions, and I will see you in the next video.